In my last video we looked at this, the Humble fuse, and we found that it will tolerate overcurrent for a short period of time, a small overcurrent for a small period of time, and if you massively overload it, it will blow pretty instantaneously. But the problem with fuses is they do exactly that. They fuse, they blow, they give up. And that means we need to replace them. Now that's not such a big deal. These things cost less than a penny sometimes if you buy them in bulk, but it does mean you have to replace them. You have to locate the one that's gone and replace it, that sort of thing. Turn off your input, replace the fuse, turn it back on again, and sometimes that's a bit annoying. Well, of course there is another option, and that's a DC breaker. And this is the one I've been using in the solar shed for some time, and to be honest, it's been a bit of a dirty little secret because I'm not convinced whether this works. It was pretty cheap from eBay, sent from China. It's rated for 80 amps, and it definitely works as a switch. I know it definitely turned the power off in that position, and it definitely turned it on in that position. But as this was the cheapest one I could find, it's rated 80 amps, and that's way over power for my solar shed. So as a result, I don't know if this works. I've never walked into the shed and found that this has tripped. So how do I know that it works like it should? Now, I'm not going to put more than 80 amps through this. That's an awful lot of power, 1000 watts or something at 12 volts. I'm not going to test this breaker, but I am going to remove it because I think I've found something better. And here it is. It's branded as a Midnight Solar 30 amp breaker, so it's much lower than the original one, and 30 amps is plenty for my 20 amp solar charge controller and my small little inverter. And here it is. It's actually made by CBI, which is Circuit Breakers Industry. And sadly, this little sticker actually goes over some of the information, and I'm not sure that's really the right thing to do. But anyway, that's what Midnight Solar have done. It's rated up to 150 volts DC, 30 amps, as I mentioned. And on the side, there's some more information here again. Max volts, 125 volts. The trip delay is a U2 curve. You can look that up in the datasheet, and you actually find it trips at 39 amps. So similar to a fuse, it will tolerate more than 30 amps at any one time, and 30 amps is its normal rating, or less than that of course. It also points out here that 125 and 240 volt DC units are polarity sensitive, do not reverse feed. And that means that this is marked here with a positive, and that should be connected to the device with the most potential. So if it's connected between your battery and your charge controller, your battery would go here. If it was connected between your solar panels and your charge controller, well, the solar panels will go in here at the bottom. But here we have three separate breakers. There we go, space in between, make it more obvious. On the left we have an AC breaker. It's for 240 or 415 volts, and this is a 6 amp breaker. In the middle we have an AC or DC breaker according to the label at the side, but on the front here it's just got a DC symbol, 80 volts maximum, and this is a 15 amp breaker. And on the right hand side we've got the 30 amp DC only, 150 volts DC Midnight Solar breaker. But why can't I use this cheap AC breaker that only cost me a couple of pounds, and why do I have to use a DC breaker that actually cost me more like 17, 18 pounds delivered? Well, the theory is that inside they're actually quite different beasts. The internal mechanism and the safety systems are quite different. But I've been researching this and I found out that's not entirely true, but there certainly are differences, so I thought it would be interesting to open these up and see the differences for ourselves. Now before we open them up, let's just have a word about the theory. These breakers should be different inside because of the different characteristics between AC and DC circuits and current. in AC circuits the power is actually alternating. That's of course where AC comes from, alternating current. And the breaker uses this to its advantage. It's able to switch off easily at these points where we cross the zero line. However, in a DC breaker, of course the DC current is constant. And at the point where you actually break the current, you're at full current flowing through the circuit. So the likelihood is that there'll be an arc. Now, as I start to open these up, please do remember that I'm not a qualified electrician, and despite what we find inside these breakers, please make sure you use the right device for the right application. Now then, so on the left hand side we have an AC breaker, and on the right hand side we have the AC and DC breaker. For the moment I'm not going to take apart this expensive DC breaker because if we can see the differences in here, I don't see the point of destroying something that I want to use in the shed. But on the left hand side, that AC breaker is there. Now I should recommend MJ Lawton's video about these circuit breakers. I certainly found it quite useful and learnt a lot. I'm not going to go into as much depth as he did, but basically we can see the actuator lever here and the actuator mechanism, and I don't think this is going to work anymore because things pinged a little bit when I opened it up. But there's the solenoid. Now the solenoid protects for high current overload. Basically, if there's a high current that goes through this device, the solenoid springs forward and disconnects the contact here from this contact here, and it moves out of the way. But I don't think I can really show that now because I think I've pretty much destroyed this one. But here's the bimetal strip on the right hand side of this model, and there's two dissimilar metals connected together, and when they heat, because they're passing current, they change their shape because there's two different metals, and again this will press against the mechanism and a bit of a hair trigger, and ping, it breaks the circuit. But this is the key to why you can actually put more than 6 amps in this case through this 6 amp circuit breaker, because it will take a while to actually move across. Now down here we have the arc divider or the arc extinguisher, and this is a group of metal plates that are isolated from each other, and as this contact moves away and an arc is caused, it is dissipated within these plates. So now onto the AC and DC breaker, and how will it be different inside? Well, clearly things are in a slightly different place here, but actually it looks very similar. We have the same arc extinguisher here, and of course that's the biggest problem with DC voltage, is the arcing that's caused between the two contacts. Now interestingly, in here I can't actually see a bimetal strip. This seems to just have the contact here, the power's coming through, and it goes to this mechanism through the solenoid, which becomes an electromagnet and moves this piston forward if it's over voltage, which then disconnects the power. Now this was sold as new old stock. I got it here in this box, and as you can see it was created in 2005. So there is a chance that technology has moved on somewhat since this was designed, and perhaps inside here it's quite different. And sadly that means I'm going to have to take it apart. Okay, so the rivets have been removed. The drill slipped a little bit on those ones. Hopefully this will open up without too much bother. Yes. And here we are on the inside. Well, look at that, it's almost identical in every way to this AC/DC breaker here. The mechanism works in the same way, and the solenoid looks very similar. Obviously the wire on this one is a bit chunkier. This is a 30 amp breaker and this was a 15 amp breaker, but the same arc divider exists here, the same mechanism as the 15, and it's incredibly similar to the AC breaker. But yet again, I can't see a bimetal strip in this DC breaker. So the only protection I can see is from the solenoid activating and pushing the hair trigger and causing it to switch off. Now there are two differences that I read about that might be quite difficult to see just from looking at these breakers. The first one is that the solenoids have a fluid inside of them. So when there's a slight overcurrent for a short period of time, the fluid actually slows the plunger down and therefore it doesn't trip and doesn't break the circuit. Whereas in an AC breaker, there isn't that fluid, so it can trip much quicker. And the second difference I've read about is about the arc divider and the arc extinguisher, and I've read that in DC breakers they use magnets to help dissipate the arc, and in fact there is a magnet on this Midnight Solar breaker right where the contact meets, and I don't think that exists, no, on the AC one, and it doesn't either on this AC and DC breaker. So please, a reminder, despite what we've seen here, please use the correct breaker for your circuit, or of course the correct fuse if that's the way you go. Don't please use AC breakers on DC circuits. As you can see, they are different. There are reasons for those differences. DC currents arc, and that's why they're used in welders as well, because DC arcs at its full current until it can no longer arc. So this has been very interesting, but please make sure you use the correct one. Have I laboured that point enough now? Hopefully you've enjoyed this video. If you have, please give me a thumbs up, subscribe down below and comment if you can. Thanks for watching. I'll see you next time. Gonna have to go in the bin these now. Now I wasn't intended to do this, but in for a penny, in for a pound, what's inside here?